Now let's do the same example algebraically. We take a quadratic equation y equals to ax square plus bx plus c, or y equals to x square minus 3x minus 10. We take the equation and see what possible values we can have for y. So there are total 3 possibilities. Y can be 0 or lesser than 0 or bigger than 0. That's all the possibilities that we have. If we look at the graph, we can have all these 3 values where y is 0 at the intercepts, y is less than 0 between those intercepts, and y is bigger than 0 or above x-axis when we have values lower than the first intercept or above than the second intercept. So we solve all of the cases. We solve y equal to 0 case where we have x square minus 3x minus 10 equal to 0. We split the middle term as we did in the previous example, and our factorization is x plus 2 times x minus 5 equal to 0. Using null factor law, we know x can have a value minus 2 or x can have a value 5. For both these values, y will be 0. Okay. Now is the main part that we want to discuss, whether y is less than 0, that becomes an inequality, or if we have y bigger than 0, that's again an inequality, and both of them are quadratic inequalities because the expression that we are dealing with is a quadratic expression. So we already have a factorized version, x plus 2 times x minus 5 less than 0. You see here two things are getting multiplied and their answer is less than 0. That means their answer is negative. So the possibility is that any one of these factors is negative. So if we have x plus 2 factor as positive and x minus 5 is negative, positive times negative will become negative. Or the second possibility would be that x plus 2 is negative and x minus 5 is positive. So negative times positive will again be negative because the overall result is less than 0. The overall y term is less than 0, right? So we take both of the cases one by one. First, we take x plus 2 to be positive and x minus 5 to be negative. We put an and in between, right? If x plus 2 is bigger than 0, that means x is bigger than negative 2. And if x minus 5 is negative, that means x is less than 5. This perfectly makes sense. That means x is bigger than minus 2 but lesser than 5. So we say x is between minus 2 and 5. So if this is minus 2 and this is 5, we take x between minus 2 and 5, and for that our y values are negative. Yes, that's correct and it makes sense. But if we take the other case, we put an or, and we take the second case that x plus 2 is negative but x minus 5 is positive. Okay, so x plus 2 is negative and x minus 5 is positive. In that case, x will be less than minus 2, and at the same time we are expecting x to be bigger than 5. It's not possible. How can a number be lesser than minus 2 and simultaneously bigger than 5? That makes no sense. So we reject this case. We say no, this makes no sense. Only this makes sense. We consider this interval. We say that take x values between minus 2 and 5. Your expression would always lie below x-axis. You will have negative values for y. If you are considering the positive values for y, so y bigger than 0, you want this whole expression to be bigger than 0. We have a split version, a factorized version of the expression, which is x plus 2 times x minus 5, and we expect it to be bigger than 0. By any expression bigger than 0, we mean to say that it should be positive. And if a product is expected to be positive, we have the possibilities that both of the factors can be positive because positive times positive leads to positive, or both of them can be negative because negative times negative is again positive. So we consider both of the cases. We say either x plus 2 and x minus 5 both are positive or both of them are negative. When we simplify it, if x plus 2 is considered positive, that means x is bigger than minus 2 and x is bigger than 5. If I say something is bigger than 2 and something is also bigger than 10, so the safe and the wise option is that we consider it bigger than 10, because anything that is bigger than 10 is by default bigger than 2, right? So in this case, I say x is bigger than minus 2, also x is bigger than 5. So there's no point considering x bigger than minus 2, because something that is bigger than 5 is already bigger than minus 2. So we will consider the biggest option, right, in the greater than part. The similar way, in the less than part, we have these two inequalities, x plus 2 is less than 0 and x minus 5 is less than 0. Resolving this, x will be less than minus 2 and x less than minus 5. So again, when we are considering a number less than some other number, we would look for the smallest possible number, because if I say this marker is cheaper than 100, or this is also low, this has low cost than 80 rupees, so you should not be guessing that it should be maybe less than 90. No, if it is already less than 80, so it is cheaper than 100 by default. So we choose the smaller value, x less than minus 2. Now in this case, we have two extreme values, or we have two endpoints connected by this OR. So my result would be that consider x less than minus 2 or consider x bigger than 5. And this is aligned with our rule that take x values lower than alpha, you will have positive values of the curve, or take x values bigger than beta and you will have positive values of y. So I give a repetition. We consider the whole expression x square minus 3x minus 10. There are three possibilities. It can either be equal to 0, less than 0 or bigger than 0. For equal to 0 case, for the equality case, we factorize it, we find both of the values where y will be equal to 0. When we are resolving or solving the inequality where the graph is supposed to be lower than x-axis, y less than 0, we take the cases that either one factor is positive, the other one is negative, and their product would become negative because y is less than 0. In that case, we resolve it and use the simple logic that it is not possible that a number be negative and positive simultaneously. So the better option is that we take the x value which is between minus 2 and 5. The similar way we solve it for y bigger than 0, and for a product to be positive, the viable option or the suitable option is that either both of them are positive, both of the factors are positive, so the product is positive, or both of the factors are negative, so the product is positive again. We solve both of the cases one by one, choose the smallest value in case of the less than, choose the biggest value in case of the bigger than, we merge them with a OR, and that's our result.